When you think of energy efficiency and the building management system, which are the systems that first come to mind that you should optimize? So if the building owner says to you that they have some money this year in the budget and they want to do some control strategy optimization, design some smarter control strategies, download them into their existing controllers, commission them, tune them, and save some energy, which systems do you think of straight away? I reckon most people think of the chiller plant room and the air handler units. And it makes sense because a large chill water plant room could draw 1,000 amps during summer. So I reckon you'd sit down with the building owner and say, look, we'll put together a fee proposal in a couple of weeks. We'll start in the chiller plant room and we'll move to the air handling units. I bet you that nobody sits down with their customer and says, you know what, why don't we optimize our optimal start module? I bet no one says that. That just doesn't sound very exciting at all. The thing with chill water systems is they're pretty complicated. They're difficult to optimize, and that means you need more man hours to do the work, and it's quite expensive. In today's video, I'm going to surprise you with how much energy you can save with an optimal start module. Like, it's not even a system. It's not even a mechanical piece of equipment. We're talking about a software control module within your controller. You'll be surprised how much energy we can save. I think the best way to explain this is I'm going to run through with you the startup sequence for optimal start warm-up here in Australia. So every single building in Australia starts like this. The first thing that happens is the optimal start module looks at the outside air temperature, the zone temperature, the time schedule, and the target temperature. And it does a calculation and it says, okay, we need to have comfortable temperatures at 8 a.m. I'm going to pre-start the building at 7 a.m. So at 7 a.m., the optimal start module flag is enabled. And the first thing we do is we start the VAV boxes. So all the VAV boxes start to open up, and all the supply and return dampers of the core open up. We wait a while, we give it a few minutes to do that, and then we start the air handling units. So 6 air handling units in the low rise, and 6 air handling units in the high rise. All the supply fans start, and all the return fans start. Their pressure switches make, and we enable temperature and pressure controls. The fans start to speed up to control pressure, and the heating valves start to open for heating. And the integral from the PI loop winds that heating valve open, 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 open. And at around about 70% heating valve open, we generate a heating demand signal for the boilers. So the boilers are sitting there, and they start seeing these heating demand signals coming in from the air handling units. So the first thing that happens is the heating system is enabled, and we start the lead boiler's primary pump. And the pump starts, and the pressure switch makes. There's a bit of a delay there, and we start the lead boiler, the burners come on, and we start to generate some heat. But remember, we've got a 30-story commercial office here. There's 30 floors here of cold water throughout this entire building. So after about 15 to 20 minutes stabilization delay, we stage up, and the lag pump comes on. The pressure switch makes, and then there's a delay for the water flow to the boiler. Then we start the boiler, the gas burners come on, and we start to generate heat. Now we've got 2 boilers that are running at full speed to try and heat up this water. That takes quite a long time. So here's the point. We started the building for the purpose of heating the building, and we ran all of our fans for our AHUs, all the supply fans and all the return fans. We ran them for about at least 20 minutes with no hot water in the pipes. Like, does that sound very energy efficient to you? Does it sound like awesome that we tell our customers that we are energy efficiency specialists and they should pay us money to do chiller optimization projects and air handling optimization projects and have building analytics and predictive maintenance and all this awesomeness because we're so awesome, but we run our entire building's main VAV AHUs for nothing for 20 minutes for the 3 months of winter during warm-up, and for the 3 months of summer when an optimal start cooling, the same thing happens. We run all of our AHUs, the cooling valve opens, the demand goes to the chill water system, and we start up the whole chill water system and we wait for cold water to come into the system. That is a massive waste of energy. And it's really easy to fix it. All we've got to do is, when the optimal start module activates, the first thing we do is we open up the air and heating water valves to say 25% open. We don't start the fans. And immediately we send a demand signal to the boilers. So that 20-30 minutes while the boilers are staging up and doing their thing and heating up all this water, while that whole stage up is happening, our fans aren't running. So in the AHU software program, it says something like, if we're in warm-up mode, only start the fans when the return water temperature is above, say, 50 degrees Celsius. Then start the fans. You don't have to even have design temperature. We don't need design temperature. We just need some warm water in those pipes. It's a very simple thing to fix. But why does this happen? And this is the key to this. Why does this happen? This happens because the optimal start module was designed in probably the 1980s. And at that point in time, we didn't care at all about energy efficiency. All we cared about was having a good, comfortable temperature at occupancy time. If we ran our AHUs for 20-30 minutes for no reason at all, that didn't matter. Energy efficiency was not a concern at all in those days. Nowadays, energy efficiency is very important, but we haven't realized that a lot of our control strategies that we think are energy efficient were actually developed 20-30 years ago for comfort control, not for energy efficiency. Optimal start module is a great example of a control strategy that by tweaking it, changing how it works, you can completely bias it from comfort control across into energy efficiency control. If you look down in the description, there's a link to the Advanced Control Strategy course, which runs through all of this, and obviously Optimal Start is one of the chapters within the whole course. It goes through chill water systems, boilers, cooling towers, AHUs, the whole thing. So this discussion right now, it's just one of the 6 lessons that are within the Optimal Start module. So go and have a look at the free preview. The free preview is Optimal Start, so you can listen to the whole thing. Before I go, I'll give you a second example of a real simple thing that we don't quite get right a lot of the time with Optimal Start. So the target temperature, that target temperature set point that we are preheating the building up from 19 degrees, 19, 20, what is the target temperature set point? So the Optimal Start module, it looks at the outside temperature, the zone temperature, the time schedule, and the target temperature. What is that set point? What do you have in your BMS design as your target temperature that we're preheating up to? So actually a lot of BMS designs don't even actually nominate what it is. Half of the FDs that I read, it doesn't actually say there what the target temperature is. So we're leaving it up to the software programmer or the commissioning technician who doesn't have time to play with that to determine what the target temperature set point is. So anyway, a lot of people say that the target temperature set point is 22.5 degrees Celsius or 22 degrees Celsius. And that's a hangover from the 1980s when we were pre-starting to get comfortable temperatures. That is not the correct set point. The correct set point is 21 degrees Celsius because the contract, the lease conditions between the landlord and the tenant, the landlord's your client, not the tenant, said that they have to provide between 21 degrees Celsius and 24 degrees Celsius between occupancy times. That's their contractual requirement. So it doesn't have to be toasty and warm at 8 a.m. It just needs to meet the lease conditions. So if you double click and change that set point from 22 degrees Celsius to 21 degrees Celsius, that set point change, which takes minutes, will probably result in your building starting 5 minutes later, because we're preheating to 21, not preheating to 22. That's really important. Also keep in mind that it's highly likely that with an aggressive heating optimal start, where we're pumping hot air into the building, if you terminate optimal start at 21 degrees C, you're probably going to overshoot to 22 anyway. So you stop at 21, and I think that's actually why sometimes not the best optimal start modules go from heating for warm-up straight into cooling, because we've got our target temperature too high, 22.5 degrees Celsius. So we heat up to 22.5, overshoot into cooling, demand for chillers. So terminate early at 21. The other thing is that I reckon if you went to an office at 8 o'clock in the morning and ran down the fire stairs and poked your head into every single floor, 30, 20, every single floor, I bet you at 8 o'clock in the morning, there's not many people there. There's like 20% people are there. They start drifting in at 8 o'clock, 8:15, 8:30, 8:45, office is full, right? So if it's a little bit on the cool side at 8 o'clock, you're probably going to get away with it, because you'll overshoot to 22 in the next 15 minutes or so as the AHUs transition into normal mode. The other thing is that when people are coming to work in winter and it's cold outside, and they've got the jackets on, their beanies and their scarves, so they come, it's outside, it's like 10 degrees Celsius. They walk into the ground floor lobby, and you've got that temperature at say 20. Yeah, it's a bit cold, but it's a transition area. So they come through from 10 into 20. They're in the lifts. They're up the floor, up onto your floor, onto their floor. It's 21 degrees Celsius. That's going to feel very comfortable. They sit down, take the coat off, go make a cup of coffee, come back, turn the computer on. Now we've overshoot into 22. So a lot of optimal start, and actually a lot of energy efficiency, is around considering people, occupants, perception of what comfortable is, and manipulating that. So let me leave you with one last thing, all right? This is it, because I'm probably running over time here. Yep. If all of our service departments in Melbourne and all of our service technicians over the next 3 months went out into the city and adapted all these optimal start modules to not run the fans for no reason, I reckon that the whole city, the air conditioning for all those buildings, 1,000 buildings, will start up 15, 20 minutes later. The whole city, the air conditioning is going to start 15 to 20 minutes later. That is going to make a massive impact, a positive impact on the power stations and the grid, putting power into the city in the morning, and the environment. Stop copying and pasting control strategies that were developed 20 years ago for comfort control.